We are starting from Module 5. In Module 5 and Module 6, we will go over Chapter 4. We will talk about data transfer, addressing, and arithmetic. So that's start for the Chapter 4, the Part 1. In Chapter 4, we will talk about data transfer instruction. That's including the addition and subtraction. So you will see those instructions will affect the status flag. And also we will talk about some data-related operator and directive. So these three sections will be in week 5. Afterward, in week 6, we will continue with the chapter 4. We will talk about indirect addressing. We will talk about more instruction, including jump and the loop. So you can see the loop and jump instruction. That's just like the for loop we will implement in C++, but in assembly language, we only use the loop instruction. So we'll see how to do that in week 6. And we will compare in the 64-bit environment how we will do those data transfer and adding subtraction operation. So the first thing that's using the first two videos, we will talk about data transfer instruction. In this video, we will go over the first few topic. So the first thing we will talk about operand type. So then we will talk about some operation including the move. So then we have different move. We also have the sign move and the zero move. So the first thing that see the operand type. Like we talk about for your instruction, our instruction is mononymic instruction. But different instruction, they were including 0 to 3 operand. For the operand, we have couple different type. The first type is we call immediate. So immediate, you can say that's immediate value. They will be a constant integer. They could be 1 byte, 2 byte, or 4 byte. So that depends on how you want to save that the constant value into the location. So the value is encoded within the instruction. So that's why we don't need to have specific memory for that. So that's an immediate value. They can be operand as well. So then work with the instruction, we can using the regist. When you're using the regist, you can just using the name of the regist to access that. Regist name is converted to a number and encoded within the instruction. So what does that mean? According to your regist name, remember, for example, we have the general purpose regist. We have EAX, EBX, ECX, EDX. But EAX is referred to 4 byte. So if you're using the EAX, your number to convert, they will save in 4 byte. But remember, we also can using AX alone. If you're using the AX, that's 2 byte. So the same thing, AL is 1 byte. So that regist name will convert to a number and encode it with the instruction. Addition to register, we also can using the memory operand. So those memory operand is with reference to a location in memory. On the other hand, the memory operand, remember that we talk about at the end of the chapter 3. Under the data directive, we can declare the data label. You tell them the data size, then you assign the value. Those data label actually refer to the location for the memory operand. So those data label actually is holding the memory address. So when you're using the memory operand, the memory address is encoded within the instruction. Or you have a regist hold an address of the memory location. So that's the 3 different kinds of operand type. From now on, we will learn many different instructions. So those instructions, how they work with the operand. So that's why we want to show you. Sometimes in the syntax, you will see the operator work with the operand. So if they call reg8 reg 16, reg 32, reg. So you can guess that's referred to regist. So regist, we have 8-bit, 16-bit, and 32-bit. So that's if the operand write like that. If they only show reg, can be any general purpose regist. But if they say reg 32, that's only for the 4 byte. So the same thing, reg 8 will be the 1 byte. So then the same thing here, if you see the syntax write IMM, that's mean immediate value. The same thing, immediate value can be 1 byte, 2 byte, or 4 byte. So then followed by the number that represent the immediate value. Sometimes they have some restriction about the size. So the reg/memory operand, that's mean memory, that's mean the operand can be regist, also can be the memory operand. So then here, right, the same thing, memory operand can be 8-bit, 16-bit, 32-bit. But if they just write REM, that's mean general memory operand. Before we introduce you the instruction, let's talk about the direct memory operand. We see how we declare and how we access that. A direct memory operand is a name reference to the storage in the memory. When you declare that, that's under .data directive. So then the name reference, that's the label we talk about. So usually when you just access by the label name, they are automatically dereferenced by the assembler. So for example, I have the val 1 byte holding the 10 in hex. So sometime in the code directive, then if we want to do the move, right? So you can move the val 1 to the AL, right? So this one actually is, remember we told you val 1 actually is the address point to the location. But because your NAND reference, they will automatically to the reference. So instead, when you have your val 1, they will just automatically to know they go to that location and read the value. So that's why we save in the AL. So then you can either write this way because that's okay. Or in assembly language, if you know that's the address, you want to dereference, we just using the square bracket. So then we know here is address, but we will dereference the value. So this one we will see in other example is sometimes we have the label is only holding the address. So that's the way to dereference that. But most of the time you see they just automatically dereference that. Okay, so then let's continue to introduce different instruction. So let's talk about the move instruction. So I know we start using the move in chapter 3, but now let me really show you in detail how the syntax work. So when you move instruction, the syntax like here. You have your move instruction. Then you have 2 operands. Of course, the first operand is the destination. The second one is the source. So we will move the source value to the destination. So you move from the source to the destination. But let's continue to talk about more. Your destination cannot be immediate value. So no immediate to the segment move. So that means your destination can be regist, can be memory operand, but they cannot be segment. So then both operands must be the same size. So what does that mean? That means here, if you have the EAX, you want to move EBX to EAX, that's okay because they both are 4 byte. But if you want to move AX to EBX, so then they are 2 byte to move to the 4 byte. It's not possible. When you have your destination operand and the source operand, they both need to be the same size. They can be byte and the byte. They can be word and the word. They can be D word and the D word. but they cannot just with the different size. So then the last one actually is important in your chapter 3 in your assignment 4. So both operands cannot be memory operand. So that's mean if you want to use the memory operand, there only can be one of that. So what the other one is? So the other one is if your destination operand is memory operand, so then your source can be a register, can be an immediate value, just cannot be memory operand. So then the instruction pointer, like IP, EIP, RIP cannot be a destination operand. So on the other hand, because important, we can have register as the destination, but instruction pointer cannot be updated by the move. That's move instruction. So that's the move instruction. So you can see more example like here. Under the data, we define one count is 1 byte holding value 100. You have wval is 2 bytes, then you have value. So in your code block, see, because count is 1 byte, so I can move to BL. Because the wval is 2 bytes, so I can move to AX. So AL is 1 byte, right? So then I can move the value to count. So then you can see they all have the same size. So then the value being updated like this. But this 3 is incorrect. So you can see wval is 2 bytes. You cannot move to 1 byte. Count is 1 byte, cannot move to 2 bytes. Count is 1 byte, cannot move to the 4 byte. So that's the move instruction. So anytime post the video to see you have any question. So then the next one, actually, I do want you to post the video to try by yourself to see, explain why each of the following move statement is invalid. Also, of course, here we have the answer. So, but one thing is I want you to cover the answer to make sure you practice with those examples. So during the before, when we are not online, of course, we will have the peer work to practice with that. So now since I have the lecture recorded, so I want you to make sure you post the video, try to write down the answer, then you check the answer. If not correct, you have question, please write down the question. We will go over during the Zoom meeting. So the next one, we will continue to talk about the move instruction. But here I will give you the example is we call the overlapping value. The reason is in the chapter 2, we start talking about we have EAX. But EAX you can access by AL, AX. Okay, did you remember we have this picture to show you? So we say the EAX is the whole 4 bytes, but AX is the first 2 bytes. Then we have AH and AL. So now we see this example. In the data, we defined a byte memory operand. Then we define a word and the word. So then we see here in your code block. So you can see here, the first beginning we move EAX equal to 0. So that's why we will see all the EAX is 0. So that's the 4 byte. Then we have the 1 byte is 78. We move that value to AL. So then you will see they only update the first 2 bytes. So that's why you see now the EAX, the whole thing become the first 3 bytes is 0. So then you have 78. Because you only access the first, actually the least significant the bytes in the first one. So then you can have one word to override AX. So AX will be override in the first 2 bytes in the EAX. So on the other hand, one word is 1, 2, 3, 4. So then you see they write like this. They override 1, 2, 3, 4. Of course, you can override the whole 4 bytes from the 1D word variable. So then you access EAX. So then you see the whole thing being override become 1, 2, 3, 4, 5, 6, 7, 8. So then if you only override AX, they only override the first 2 bytes.